Next.js is an awesome framework. I've been using it for years now. It lets you build UI using React components, give you file-based routing via the app router if you use the app router via Next.js, and comes with server components and SSR built-in. You can create API routes for backend logic, or even use server action instead if you want to use that. With all of that in place, the real question is, can we truly call Next.js as a full-stack framework? Okay, let's begin. Personally, when I want to find accurate information, I go straight to the source of truth, the official Next.js documentation itself at next.js.org. The docs are clean and well written, so let's dig in. Scroll down a bit and you will find a grid card that clearly labels Next.js 16 as a full stack, at least from a front-end perspective, right? At this point I was like, okay, interesting, but what does full stack actually mean here? Okay, so now I want to validate this full stack claim. Let's start with something fundamental, authentication. Let's over to the Next.js official authentication docs, and we get this page of how to implement authentication in Next.js. I scroll down a bit, and wait a second. In the example, there is an import DB statement, but here's the thing. This page never explains how that database is actually set up. So naturally, you do some digging, and what do you find? You need an ORM layer, right? And that means reaching for popular third-party tools like Prisma or Drizzle. They work great, but let's be clear here. They are not official Next.js tools. Now let's compare that with something like Laravel. Laravel have eloquent ORM. It's built-in, official ORM, no guessing, no third-party dependency. It's part of the framework itself. Okay, let's jump into the terminal and do something real here. I'm going to initialize a fresh Laravel project by running this command, Laravel new Laravel init. Laravel init is just the project name. For the starter kit, I think I will choose React, and Laravel takes care of the rest, installing all the packages and dependencies. Once that's done, we get this check mark. Everything is ready. And notice this, Laravel also initialized the database setup for us right out of the box. So now, I run cd into my Laravel init, open it in my editor with code dot, and here we are inside the project. So here, the first thing I want to check is the .env file. This is basically the core configuration file for almost any modern application. I scroll down a bit, and there it is. DB connection equal SQLite on line 23. And this is the key point. At this stage, I am only configuring the database connection, not the ORM. By the way, I'm not making this video just to overclaim things or just doing surface level research. I've actually spent years working with Next.js in real-world projects. One of my repositories alone has 1,400 plus commits, and I am responsible for over 90% of them, with 99% of the code base written in TypeScript, because I built full-stack JavaScript application end-to-end. And this is my main tech stack, includes Next.js, Prisma, Redis, cloud services, and supporting infrastructure around that ecosystem. The project was delivered as a client product. If you're curious, you can visit wahyusaputra.com in the browser, and then go to the career timeline section, and you'll find a project where I work as a full-stack developer for an Upwork client. And also, on top of that, I am also the founder and technical educator at Pixel Developer. This video is published on the Pixel Developer YouTube channel as well. And we also run pixeldeveloper.io, a learning platform focused on actually writing code, not just passively watching videos. Everything is hands-on, from interactive quizzes, like testing your understanding of primitive versus object in JavaScript, to fill-in-blank challenge where you actually type the answer directly on the site. If you get it wrong, it immediately shows you a hint so you can understand why it's wrong and correct your answer right away. And even full coding exercises where you run real code in the browser and make it pass actual test cases. Think of it like lead code, but focus on real-world programming concepts, not just abstract puzzles. Right now, I've just launched the first course, TypeScript Basics. The original price is $39, but it is currently $19. 50% off, limited to the first 97 people. Alright, let's go back to the terminal. This time, I'm going to initialize the latest Next.js project. I will name it Next.js Full Stack. Hit enter, and Next.js scaffolds the project for us automatically. Okay, now setup is done. So I'm doing cd into Next.js Full Stack and open it in my editor with code space dot. And here we are, a fresh Next.js application. Now, notice something interesting. There is no .env file here. Nothing. In a modern application, the .env file is basically the core configuration layer. But in this case, Next.js doesn't generate it for you. We have to create it ourselves. So okay, let me do that from scratch. I create a new file called .env, then hit enter, and then I will manually add some example environment variables. Database URL, then next out secret, and then next out URL. Everything is typed in by hand. Now let's compare this with the Laravel approach. I open another terminal and run new Laravel Full Stack. Laravel Full Stack is just the project name. Then I choose none for the starter kit, wait for the installation, and once we see the check mark, I open it in my editor with code space dot. And here's the difference. Right away, Laravel gives us a .env.example file. We are not starting from a blank slate. We already have a structured environment configuration that we can simply copy and adjust. So instead of manually creating everything from scratch like we did in the Next.js app, Laravel gives you a clear, opinionated starting point from day one. Alright, and next let's talk about something I call JavaScript paradigm confusion. JavaScript was created back in 1995, and originally it was purely a browser language, client-side only, right? For example, if we open the browser's DevTools console and type something like console.log hello from the browser and then hit enter, the code runs instantly. No terminal, no server needed, just the browser executing the JavaScript. If we look in the timeline, fast forward to 2009, we got Node.js. Now JavaScript can run on the server. So here in the terminal, I type Node, click enter, and then write console.log hello from the server, then hit enter, and we got the output. Same language, completely different environment. Last, let's jump to 2016 when Next.js enters the picture, and this is where things start to get tricky. Here's my Next.js app. I have two components. Let's open userprofile.tsx first. This one is a server component, and you can tell because it's an async function. That means I can do server-side things here, like fetching a user from the database. In this example, I'm using a Prisma-style query and awaiting the result, which makes totally sense in a server context. Then I return some JSX markup, and when we fetch data from the database, we use the await keyword, which makes sense, right? Because async and await are designed to work together. Here is where the problem starts. I add an onClick handler that logs click, and intuitively, this looks fine. It's still JavaScript, right? But here's the catch. OnClick only exists in the browser. You cannot click anything on the server. So what happens? Okay, let's go to the browser, and we got a runtime error, marked as a server error. Runtime means that the app itself crashes while running, not while typing our code inside the code editor. And the error message clearly points to the exact line where I use onClick inside a server component. It's a great error message, by the way. So we go back to the editor, remove the client-side onClick handler logic, save the file, and go back to the browser. And now everything works. The data loads and my name is displayed correctly. And this is the key takeaway. In server components, you cannot mix server-side actions like fetching data from a database with client-side interactions like click event handlers. Even though it's all JavaScript, the execution environment still matters. Okay, let's move on to the next component, counter.tsx. This one is supposed to be a client component, so notice the function isn't using the async keyword. Inside, I add a simple button with an onClick handler, pretty standard client-side stuff. Now let's go back to the browser, and we still get an error. Why? If we zoom in on the error page, it says build error. That already gives us a hint. This isn't a runtime issue anymore. The app fails during the build step, which makes sense because client-side code is validated at build time. So what is the actual error message? It says use state only works in a client component. And here's why this happened. In Next.js 16, when you are using the app router, every component you create will mark as a server component by default. So even though this looks like a client component, Next.js still treats it as a server one. To tell Next.js otherwise, we need to be explicit. At the very top of the file, we add the directive of use client. Save the file, go back to the browser, and the error is gone. Everything works as expected. And this is the real takeaway. Whenever you write client-side logic like state, effects, event handlers, you must mark the component with use client directive in top of the file. Which also means we now carry a new mental checklist every time we create a component like, is this a server component? Is this a client component? Or do I need both? And if so, how do I split them properly? That earlier paradigm confusion doesn't just add another mental checklist like, is this a client or server component? It also affects how environment variables work. In Next.js, your .env file is no longer a single environment. It's effectively two environments living in one file. Let me show you what I mean. I open my .env file and start adding some variables. First, database URL. This one is server only. It's loaded exclusively in the server environment. Then I add API secret and Jod secret. Same thing here. There are also server-side secrets. Now look at the last two. Next public API URL and next public side URL. These are client-side variables. And they must have the next public prefix. Without that prefix, the client cannot access them. So what's happening here is interesting. We have two different execution environments, server and client, running on two different machines, but they are configured in a single .env file. Let's validate this with real code. I open another editor and navigate to route.ts. This is clearly server-side code. You can tell because it's using the async keyword. I assign all the environment variables to const, then simply console.log each of them. Now, when I open the terminal and start the Next.js app with the npm run dev command, click enter, the app is now running on port 3000. Okay, in another terminal, I run a curl command to localhost 3000/API, since this is a Next.js API route. Hit enter, and we get a successful response from the server. But where are the logs? They are not in the browser. They show up in the server terminal where Next.js is running. Here, if we scroll a bit down, we can see that every environment variable we log is printed out, including the public ones. And this is the key insight. On the server, you have access to all environment variables, both server-only secrets and public ones. The separation only really matters once you cross into the client environment. Now let's move over to our client-side page, dashboard, page.tsx. I do same thing here. I assign all the environment variables to const and log them using console.log. Let's open up the browser because this is a client-side code. To see the logs, we have to open the DevTools console, and once we do, the difference is immediately visible. Some of the values show up as undefined. Those are coming from server-side environment variables that don't have the next public prefix. Meanwhile, API URL logs as http://apiexample.com simply because it uses the next public prefix and is allowed to be loaded on the client. But it is not just that server-side and client-side environments access environment variables differently. The CLI does too, and this is where that idea of adding glue to a Next.js app really shows up. Earlier in this video, I mentioned that to integrate things like database access into a Next.js app, we rely on third-party tools. A common example is Prisma as the ORM. So let's take a look at prisma.config.ts. This file is basically the glue that connects Prisma to our Next.js application. Inside, you will see the usual boilerplate. I even added a console.log for database URL, accessed via process.env database URL index array. The question is, does this environment variable actually exist here? Let's test it. I open the terminal and run a simple command, npx prisma migrate status, just to check the Prisma connection. And right away, the first output says database URL is undefined, followed by a Prisma error, because Prisma obviously needs that database URL to work. So what's going on here? The key detail is that Prisma runs in a Node.js CLI environment, not inside Next.js itself, because Prisma is not built in with Next.js. And in this context, environment variables from .env are not automatically loaded. To fix this, we need to explicitly load them in prisma.config.ts. I add import .env/config. That one line tells Node.js to load the environment variables into process.env. Now let's run npx prisma migrate status again. And this time the output shows the actual PostgreSQL URL instead of undefined. And the command runs successfully, no errors. So, the big takeaway here is this. With a single .env file, we are actually dealing with three different execution contexts: the client, the server, and even the CLI itself. Each one has its own rules for accessing environment variables, and understanding that is crucial when you are building a real-world Next.js application. Okay. Let me show you another source of decision fatigue in Next.js. Now let me show you another layer confusion. Let's go back to the official Next.js authentication docs of how to implement authentication in Next.js. If we scroll all the way down to the bottom, we will find a list of authentication libraries. And yep, here we go, another glue point. Instead of a single opinionated solution, now we are again presented with a whole menu of choices. So now you have to build a decision tree in your head. First question, do you want to self-host or not? If not, you are looking at hosted solutions like Clerk, Auth0, Kinder, or Desktop. If you do want to self-host, your options include BetterAuth, Nextauth.js, Log2, or Ori. If you ask me for recommendation for hosted auth, Clerk is a solid choice. For self-hosted setups, BetterAuth or Nextauth.js are usually my go-to options. But here's the real point. Before you even write authentication logic, you have already added another layer of cognitive overhead. More choices, more trade-offs, and more glue. And that's the fundamental difference compared to something like Laravel, where authentication is part of the framework itself, not a decision you have to reinvent every time. Another thing I personally don't like about Next.js is what I call unopinionated chaos. In simple terms, there is no solid or standard project structure. For example, let's look at freshly initialized Next.js app. Out of the box, you get a basic app directory with a handful of files. Simple, clean. Now, compare that with a popular open source Next.js project like dap.co. It uses a monorepo startup. Suddenly, you are looking at an apps folder, a package folder, and multiple layers of abstraction. This structure is completely different from the default Next.js scaffold. And here's another real-world example, cal.com, also built with Next.js. Once again, totally different structure, different conventions, different folder organization, different mental model. These three projects all use Next.js, but their structure are entirely different. Now, let's compare that with Laravel's more opinionated project structure, the solid, well-defined one. When you initialize a new Laravel project, you immediately get a familiar layout: app, bootstrap, config, database, public, routes, and so on. This structure is clear, predictable, and easy to reason about. Now let's look at a real-world example. Techcoolify, a popular open-source project built with Laravel. You will notice the same core structure: app, bootstrap, config, database, public, routes. It feels instantly familiar. Let's check one more example. Monica, another open source project that also uses Laravel. And once again, the structure is exactly what you expect: app, bootstrap, config, database, public, routes. Different projects, different domains, but the same foundational structure. Another thing I really like about Laravel is its clear and predictable architecture. There is no confusion about what runs on the server and what runs on the client. Let me show you this with a real example using Laravel Inertia and React, which, by the way, this is the same stack I'm using to build pixeldeveloper.io. First, let's open web.php. In Laravel, this file is the main entry point for defining routes. So I add a get route for /dashboard, and when that route is accessed, it triggers the dashboard controller of index method. And let's navigate to dashboard controller.php. Inside the index method, I will return an inertia response. The first argument is the page name, dashboard, and the second argument is the data I want to send to the front end, like user and stats, which includes nested data such as post count and comment count. Now let's move to the front end. I open dashboard.tsx inside the pages directory. Here I define a TypeScript interface for the props to get end-to-end type safety between the backend and the React front end. The props include user with name and email, string, and stats with post and comments, number. Then I simply render the UI. I add an h1 tag that says welcome and displays user.name. Below that, I create div, render stats.post for the post count, and then stats.comments for the comment count. And that's it. It just works. If we zoom out and look at the big picture, the structure is very clear. Server-side logic lives in app and routes. Client-side UI lives in JS/pages. The responsibilities are clearly separated. It's simple, predictable, and solid, and that clarity really matters when you are building and maintaining real-world applications. Here's the exact code if you want to see the clear architecture of Laravel Inertia in action. In left, dashboard controller, we send the data from the server, and in the right dashboard page, we simply consume that data on the client. That's it. Straightforward and easy to reason about. So, to summarize what a batteries included framework looks like in Laravel, let me walk through it quickly. I will initialize a new project in the terminal using Laravel new, Laravel full stack command. From there, Laravel guides us through a few clear choices. The starter kit, I will pick React since that's my preference. Authentication, I will use Laravel's built-in auth. which is powered by official Laravel packages. Testing, I will go with PES. And finally, Laravel Boost, which enhance AI-assisted generation for the app, something Next.js doesn't provide you out of the box. After the installation finish, we already have authentication, database setup, TypeScript, and more, all wired together. There is no confusion about which third-party libraries to pick, because Laravel gives us a solid default and a clear mental model from day one. In the end, I want to say this to all of you. The choice is completely in your hands. If you want to use Next.js, go for it. If you want to use Laravel, go for it. As always, it depends. For me personally, as a solo founder, I tend to recommend Laravel. As solo founders, we are not just coding, we are also doing marketing, content, and a lot of other things. For example, this motion graphic video alone took me a full month to create. There are just so many variables to manage. That said, I'm not saying Laravel is the best choice for everyone. If you look at the job market, JavaScript roles might more abundant than PHP. So again, it really comes down to your goals, your context, and your priorities. The choice is yours. Thanks for watching, and I will see you in the next line. Thank you.